Hello everyone, this is Kingsine. Today, we're excited to bring you an introduction to the distance protection test module in KRT software. Firstly, let's understand the core concept. Distance protection function testing and protection relay testing is a critical step to ensure that the line protection device operates correctly, reliably, and rapidly during a short-circuit fault. The core of distance protection lies in measuring the impedance between the fault point and the protection installation point. Based on this impedance value, it determines whether the fault is within the protection zone. Now, how does KRT simplify this critical task? Unlike traditional solutions, our module maintains KRT's signature advantage, perfectly balancing advanced capabilities with intuitive operation. Anyone can master it immediately. So, let's dive right into it. Now, let's check out the distance protection test module. For the distance test, we use Schneider P444 and Kingsine KF86P. We connect one group of voltage and current channels, and one pair of binary inputs for trip signal capture. The very first step we have to do is to upload the setting value from the protection relay. Now that hardware connections are established, let's proceed to distance configuration. First we export the configuration file from Schneider in .xrio format. And then we back to KRT, select the test template for the relay which can be found in our template library, and then import configuration file we just export from Schneider software to the KRT. So that is the method for setting value input with test template and configuration file. Also, we can set the configuration manually. If the relay doesn't support automatically configure parameters with template and configuration file, we can try to manually input setting value. First, we configure the test system by defining critical parameters, the protected line length, its impedance angle, voltage transformer installation position, and current transformer star point grounding configuration. These settings establish the baseline electrical characteristics for accurate relay testing. If we are simulating ground fault, we should set ZL grounding factor here according to the relay configuration, which corrects voltage measurement distortion caused by zero sequence current in ground faults. ZS coupling factor corrects ground fault distance measurement by countering line impedance imbalance. KRT offer three setting approaches: KM, RE over RL and XE over XL, Z0M over Z1M. All three methods ensure accurate relay operation by adapting to the line's unique electrical characteristics. And here we can add multiple protection zones for distance. First we click Add to add distance protection zones. To the distance protection zone we added, we can click to edit trip type, fault loop and trip time according to actual relay configuration. After all the configuration is finished, click Apply. After clicked Apply, the impedance characteristic will be shown in the main interface. User can directly click the diagram to add multiple test points according to the different fault type. In this method to add test points is called shot test. We also have another method called search test. Search test determines the boundary points of an impedance zone by scanning the impedance range. Test lines can be plotted either by dragging the mouse cursor across the impedance zone or by configuring a sequence to add test lines. After all the parameters is finished, we can start the test. During the test time, we can see the real-time voltage and current output vector diagram on the right top side. Once the test is completed, based on the test results, we can assess the whole protection test as passed, failed, or not assessment in Assessment section. Moving to report setup, here we can upload custom logos, add descriptions, and select long format reporting. Next, navigate to Test Object where we preview the full report layout. After verifying all details thoroughly, simply save the finalized report. This completes our workflow. Thanks for watching our video.